everyone, I am Sneha, co-founder and CEO DevCompass, and I am back again. Super excited to see you guys, and I really hope that you are equally excited. We have officially entered the stage 5 of the course, and this particular section is my personal favorite. I did mention this in stage 1 as well, that every time it is about the context window. How does AI start hallucinating when you enter into endless conversation with it? How should you solve for it? Everything is like a very interesting problem and a very common problem for people to solve, and this entire section is going to be about that. For everyone else who has zero context of what I am talking, please head over to devcompass.ai and you will get all the relevant information about our Claude certificate preparation course, and then hope to have you guys join us. Okay, let's get started. So in stage 1, video 3, the context window, where we discussed about it being Claude's working memory, we showed the conversation stack growing with every turn, and then left a note that every turn adds to the context. Then we picked it up in a later slide, and then we also mentioned that we're going to discuss this in stage 5, and this is that moment. So 3 months into production, there's a specific complaint pattern in the failure logs. The agent starts a conversation, handles the first few turns really well, but on long conversation, the ones with 8, 10 or 12 turns, it starts losing track of what the customer originally asked. It escalates something that we already resolved 4 turns back. It asks for information the customer already has provided. The conversation log is there. The information is there. Claude just isn't acting on it anymore. This is the lost in the middle problem. We have discussed about it in brief in the previous sections. It is predictable, it is measurable, and it has a specific fix, and this video will cover exactly that. So let's start. Lost in the middle problem, why long Claude conversations always end up degrading. So let me show you what the research literature has established. And what it means practically for our agent. So if you look at the attention pattern diagram on screen, the horizontal axis is the position in the context. Left is the start of the conversation, right is the most recent turn. The vertical axis is reliability of recall. So how consistently Claude acts on information at that position. So if you look at the shape of the curve, which is high at the start, which is the system prompt, the first user message, the early turns, high at the end, the most recent turn. So high at the start, high at the end, which Claude has just read, okay? But there is a dip in the middle, the turns that come before recent but after early. This is lost in the middle effect. It isn't that Claude forgets. The information is there. Claude reads the whole context every turn, but its effective attention, the information that it reliably acts on, peaks at the edges. And if you remember, we have discussed this with a really funky and cool diagram where we used Claude as a sun symbol and the sunlight on the spotlight. So that is that context. So if you look at the 2 annotations, system prompt always has high recall, and at the right annotation, the most recent turn always have high recall, but the center annotation says turns 4 to 14 is degraded recall in long sessions. So for shorter conversations, 3 or 4 turns, this doesn't matter. Everything is near the edges. For long turns or conversations like 10, 15, 20 turns, the original complaint, the customer's account number, the context they provided early on, all of it slides into the degraded zone. The agent isn't being careless, to be honest. It's operating as designed. The problem is that the design doesn't account for this. So let's see a failure in the actual logs. Left side is a real conversation. Customer opens with, I need to report a damaged item on order 4821 and I also need to change my delivery address for all future orders. Two distinct requests, both present at turn 1. Turn 2 through 6, the agent handles the damaged item, reasonable. 4 turns of back and forth, photos requested, refund initiated, very good. In turn 7, the agent says, look, is there anything else I can help you with today? The delivery address request gone. It was in turn 1, it is still in the context, but turn 1 is now 7 turns back, sitting in the degraded zone of a 10-turn conversation. The agent has effectively lost it. But if you look at the right side, the same conversation with the correct fix applied, turn 1 is the same, but now there's a persistent case facts block at the top of the context. A structured summary that the agent updates and maintains throughout the conversation. It captures the original request explicitly, like damaged item order 4821 in progress, delivery address change is pending. That block stays near the top of the context. High recall always. Turn 7, the agent says the refund for 4821 has been initiated. I also see that you asked about updating your delivery address. Let me handle that now. Same conversation, same information, but different architecture. One of it forgets, one doesn't. And I think with everyone who is building using these AI agents or these AI tools, we have all gotten into this habit after vibe coding a bit that you should always ask the tool to maintain a context, a markdown file of the progress and keep updating it so that it doesn't run out of context every time. Okay. Now, the fix has 3 components. First, the persistent case facts, a very structured section of the context that lives near the top. After the system prompt, before the conversation history, it's not static. The agent keeps updating it. When the customer mentions a new request, just add it. When a request is resolved, update it. When the conversation gets long, this block is what Claude relies on. It reads because it's near the top of the context. The system prompt instructs the agent to maintain this block and check it before every response. And you will build this in the walkthroughs. The second section is a structured case format which has 3 fields per item. Request description, the status pending, resolved and any relevant IDs. Explicit and perceivable. So not a free text summary, not prose, a very structured block that Claude can read unambiguously. The status field is what prevents the turn 7 failure. The agent checks pending items before closing a turn. And the third is the system prompt instruction that ties it together. Before every response, read the case facts block. If any items are pending or in progress, address them before asking if there is anything else you can help with. One instruction applied every turn. This is the enforcement layer for the case facts block. Not the block itself, but the instruction that makes agent use it, and both are equally important. Now, the diagnosis question is, which the walkthrough will kinda take you through, is given a 22 turn conversation log, find what is buried, find what is bloating and restructure it. Okay, so left column says what causes burial. Long tool results injected at turn 2 or 3, like large JSON responses sitting in the middle of the context, maybe multiple document injections, policies, help articles, which is added during the conversation. The original complaint, which was stated clearly at turn 1 but is now 12 turns back, each of these pushes important context further into the degraded zone. Whereas the fix is large tool results, please truncate to the fields Claude actually needs. Don't inject the full database response. Extract the relevant fields, return them cleanly. Multiple document injections, summarize inline rather than injecting full documents. A 2-sentence summary maybe. Near the current turn is more reliably recalled than a full document policy from turn 3. Original complaint, promote it to the case facts block, move it from turn 1 into structured block near the top. So the diagnosis is mechanical. Once you know what to look for, the walkthrough will take you through it, and in that case use this table to kind of work through it and figure it out. Now we will see the multiple scenario diagram. We have seen it before. This one's clearly updated right now for stage 5, and we will see that what has been added before. So in the last video for stage 4, we saw how we have moved from stage 1 to stage 4, the full architecture from single agent, hooks, MCP, coordinator, sub agents, Claude code dev layer, extraction pipeline, CI, everything from prior stages. The stage 5 is the new addition for this video, which is the reliability layer, a small ambered border block which is sitting between the system prompt and the conversation history. So it says case facts block, persistent context anchor. Okay, so that is like stage 5.1. That's what we built in this video, a structural addition to the agent's context architecture. So we have made the amber border intentional because we have been telling you that this every time you see the amber border, it is about enforcement layer, it is about code and instruction and not just hook. It's the same convention as hooks in stage 2 and coverage annotations that is coming in video 3. In the end, we have a stage label at the bottom which says hardening against production failure modes. This diagram kind of accumulates one new element per video. By the end of video 6, all 6 failure modes will be visible here, so be ready for a very clustered diagram. But this is just to show you how far you have come from stage 1 building single agents to stage 5 where you're dealing with everything. So that was it for this video. We discussed about the lost in the middle problem, how recall is high at the entry as well as the exit, like at the edges, and degraded in the center. The fix could be persistent case facts block, structured, agent maintained, and maintaining the context at the top. And the third diagnosis would be find what is buried, what is bloating, restructure it with the right framework. So now, in this video, everything that we have discussed, the context degradation problem is now solved, or at least symmetrically managed. But there's a second failure pattern in the production logs that's more subtle and harder to diagnose. The agent escalating conversations to human agents when it shouldn't, and not escalating when it should. So there is a clear confusion. The problem is in how the escalation criteria was written. The next video is going to be about that, specifically what escalation criteria that actually work look like and why sentiment based criteria are a trap. Interesting, right? So I will see you in the next one.